few people. So a few people might still join, but yeah, welcome everyone to our first remote Nerves meetup. It's hopefully a place, so we're going to start off kind of focused on one project, which is building a little sprinkler controller. As far as I can tell, this is sort of, this is a smallish size problem in the world of embedded space, because it's just a couple of switching things on and off with pretty minimal logic. And so hopefully that's a good place for us to start. A lot of us are new to Nerves, and so this is going to be very much like a we're learning together thing. Not a ton of expertise in the group at the moment, but hopefully then once we get through building sprinklers, we'll move on to other projects and let people start to present on just anything they're doing in the world of Nerves and embedded devices or Elixir, and just kind of broaden out the group at that point. So this week we have 4 people on the call so far. My name is Michael Reese. I live in Utah. I work, background is mostly in PHP and then Ruby and then Elixir, and still write a good amount of Ruby at my job currently. I don't really have any professional interest, or I have no professional use case yet for Nerves. But when I was in college and I was learning to program, and all my friends were learning to program because they wanted to make games, for me it was always about robots. Like, I just want to be able to build my own robot. It's my life's ambition. And so Nerves is hopefully a step in that direction for me. And then I figured we can go around the group here and kind of do introductions for everyone else. And then we'll have a couple of quick presentations by Frank and by Todd. So maybe Todd, do you want to introduce yourself quickly?
Sure, thanks, Mike. Todd Resudek. I live in Colorado, and I am a professional Elixir programmer by day, and I am a hardware enthusiast by night. And so I've done a bunch of work with Arduinos and other like C and C++ type systems on embedded systems. But I enjoy how easy it is to program in Elixir over those languages. And recently had my first foray into Erlang. And I can see why a C programmer would like it. And I also don't want to do it again if I don't have
to. All right, John, do you want to give us a quick intro?
Sure. I'm John Carstens. I reside in Idaho Falls right now, and it's fantastic. And I work for MX, which is actually primarily a Ruby shop, until Mike was convincing them to do Elixir, and then got me involved with it. And now I much prefer Elixir. So kind of semi-professionally work in Elixir, but I really enjoy automation tasks and mixing hardware, and so that's what's kind of drawing me to Nerves. I've now got tons of ideas of things I'm going to do around my house that I can quickly deploy with this embedded firmware, so it's fantastic.
Nice. John, by the way, is being a little bit modest there. He helped me build and maintain a couple of production systems that were non-trivial. They had a lot of logic going on, and they had a lot of throughput. And needed to be up all the time, and so, you know, I'm glad that I could rope you in, John, but also you taught me quite a bit along the way. So I just want to clarify that. Frank, do you want to give us a quick intro?
Sure. I'm Frank Hunleth. I'm in Maryland. I'm calling in from Maryland. So I have been an embedded systems programmer for my entire career, mostly C, C++, and then I started switching over as a hobby to do Erlang and Elixir, and now I'm doing embedded Elixir with Nerves professionally. So I'm the co-author of Nerves, so I'm totally thrilled that this group is going. So I hope you guys the most success, and hopefully I can help out a little bit too.
Nice. Well, we're super glad you could be here. Maybe we'll, Maryland's a few hours in advance. We schedule this meetup kind of in the evening times right now, mostly because I have young kids, and I'm pretty dead set on like not being on my computer while my kids are still awake so that I can be spending time with them. But but Maryland is 2 hours further in advance, and so Frank, we appreciate you being up late. But we'll invite you back as things keep going, or maybe if we get stuck on things. And we all totally appreciate the work that you've put into Nerves. So with that being said, actually, it's probably a good time for us to kick off. Frank, if you want to give us kind of a quick overview of Nerves, maybe if you want to lay out a little bit of what led you to build Nerves, the problems that you think it solves. And sure. Yeah, and then Todd will give us a little bit of an intro after that into sprinkler systems, the basics of how they work, and the electrics involved there. And then we'll talk after that about kind of what will be coming up in the next meetup.
Sure. So Todd told me I had maybe 10 or 20 minutes. So I have a couple slides. They're mostly pictures, so I can show. Well, let's see if I can share these. Share my laptop. All right, so can you guys see this?
Yeah, I'm seeing it.
Okay, good. So this is a presentation that I've given to a few other places, just mostly to people who aren't familiar with Elixir. So you guys drive it however you will, especially since we have a small group. But I wanted to show some of the use cases because I think it kind of helps get an idea of where Nerves fits in, and then a little bit of the high level of the pieces of Nerves, because since you're just starting it, I was thinking it might be useful to know. Well, actually, not all of you are just starting it, but sometimes it's nice to take a step back and see kind of where the big parts are, because once you start using it, you kind of get into some of the nitty-gritty details and might get lost for where things are going. But the overview is Nerves is just a collection of tools in some libraries, and just for creating embedded systems with Elixir. It's so the whole a lot of libraries have sprung out. Justin Schneck and I and a few others maintain the core pieces for writing code in Elixir and then have it run on more open platforms like Raspberry Pis and BeagleBone Blacks and others, things like that. And we provide some of the base libraries that pretty much everyone's going to need. And then the community has built quite a few other libraries unbuilt that use it. And we, of course, have built some of our own on. And the idea is that you can get started there, and the core parts are extensible. So if you actually want to make a production device, you can do that. So there's this is kind of a level setting thing. There's like a million ways of creating embedded systems. And depending on which conference I go to, some of these are bigger than others. I've been to ones where it's JavaScript all the way for embedded, and that has some cool features in its own right. Others, it's Rust all the way. There's certainly a lot of C and C++. I can't deny that. That's where I pretty much lived. But there's a lot of everything, and I think Nerves and Elixir have an interesting little piece of this whole thing. And I'm just going to skip over here. And since all of you have some familiarity with Elixir, you kind of know that it has some strong points with networking. And that's kind of where we push it for the embedded side. There are a lot of devices that people are making that are networked and manage a lot of different things going on concurrently. And I can show some examples. So you guys feel free to chime in. I can no longer see people's faces when I'm presenting. So, if someone's like giving me some weird look, just speak up and I'll stop.
Yeah, actually, sorry, do you mind if I ask a quick question?
Sure.
So you mentioned your background is all embedded systems, and before we started the recording, you mentioned that you're mostly a C++ programmer in that history. Is that right?
Yeah. Yeah. So, yeah.
Oh, go ahead.
So I started in telecom and working on a this switch that would bridge the kind of the legacy or the traditional telephone network to send calls over the IP network. And back when I got into it, that was a really big deal. Now it's it's kind of just the normal way of doing a lot of this. But we had, our system was had quite a, I forget how many hundreds of thousands of calls that could go through it simultaneously, but it was a decent amount. And a lot of the problems we ran into were issues of concurrency, and that kind of got me into Erlang. And that's I had been poking in a lot with Erlang because what the Ericsson group did with their switch was pretty elegant on many facets of it. And Nerves has been pretty much my route to figuring out how I get more Elixir, and well, at the time it was Erlang, into embedded systems. There are a lot of the concepts that get promoted in the Erlang and Elixir communities resonate quite well with embedded. There's just possibly a barrier because people are used to, at least in the embedded communities, are more used to the low-level C tooling. But there's a lot of overlap, and I think that's there's just a little bit of a bump to getting some of these tools into Elixir, into these devices, and that was kind of the point of Nerves. So it's to smooth that bump down so it'd be easier to adopt.
Awesome. So one just quick follow-up question, and then I'll be quiet. Sorry, I'll let you get through your slides. I've always kind of had the impression, so when I was still in college, I tried really hard to get into embedded devices, obviously. And at the time, I remember that almost everything I found was kind of like, it seemed like it was a lot of Atmel products. And so it was like some subset of C that you programmed, and you needed some proprietary cable or, programming thing to get it onto an actual chip. You had to be like down in the watchdog timers to kind of get things done. And then later on, like kind of towards the end, I graduated from school. I remember buying myself a Roomba and being so excited. And then when I like started trying to take it apart, and I realized that like the control board for it was, I don't know what hardware is on there exactly, but it's like kilobytes of RAM from what I can tell. And so I have this impression that like most of the majority of production embedded systems that are shipping to consumers are still very much built in like the kind of old school firmware style, if that makes sense. Like they're not using very many high level languages for those types of devices. Do you think is that accurate, or is that changing?
It's a mix. The one thing about the embedded field, there are a lot of devices, and they range in capability from pretty much the ability to do almost nothing, maybe a fraction, not even a million times a second of doing nothing, to one system I was working on. They had these crazy NVIDIA GPUs and that were bundled in with an embedded x86 board, just because they had some particular algorithms that ran on GPUs well that they needed for the thing that they were making. So there's definitely a lot that's really C and C++, but there are a bunch of systems now that have displays and user interfaces, and it's getting a lot more popular to design those user interfaces using either embedded web browsers or the Qt toolkit, which you end up doing a bit of JavaScript programming with how they write their user interfaces. There's another example. There's a medical device I worked on a couple of years ago. We actually extensively used Lua inside of it. The device was sold both to practitioners and to researchers, and the practitioners weren't going to do any Lua coding, but the researchers, they very much were, and they modded this device to do crazy stuff because they had that full programming language. And we eventually started programming a lot of the device in Lua itself. So, and I've heard from my friends that Python is being used quite a bit in their projects. So their projects are more industrial. So I guess less constrained on the CPU processing power that they have, because more of the cost is going into the sensors and actuators connected to the board and the humans. that are programming it because they're not making a ton of these devices. But I'm pretty sure that you can find just about anything. I've heard some crazy stuff. People have told me about Ruby in embedded projects. I'm pretty sure that pretty much every language has been used at some point. Oh, I just had a project that had PHP in it. So there you go. It's got to be everything.
If someone did it with PHP, then they'd probably have all the bases covered.
Yeah. No, it's just one on. Someone was telling me about one where they had Lisp in it, which I thought was really cool. They'd actually embedded Lisp interpreter and did quite a bit with it. So
that's awesome.
So
sorry. Thanks for answering my question.
Yeah. So let me just give you a couple of these examples of where Nerves is being used, because I think it's really helpful. I mean, it answers your question a little bit more, but things that you may not normally think of. And so Roast Point was one of the initial Nerves adoptees, and this little box thing that they have right here that says NMEA talkers and Ethernet and listeners, and that little box that has a BeagleBone black inside of it, and with some custom hardware, and that connects to a lot of the sensors and different parts going around these boats that you see. So there's tugboats, towboats, and medium-sized yachts. So my understanding is that their market is not too fancy of a yacht and not too cheap of a yacht, but mostly these tow and push boats. And they aggregate the sensor. They aggregate pretty much everything that's going on the boat, and send it to where the captain of the boat is sitting for kind of a full boat view. And this thing, they have some pretty high deployment through Mississippi River traffic, among other places. So this one, their interest in Nerves was they deal with a lot of messaging between all the sensors and shipping things back and forth. And Erlang and Elixir are kind of a good fix, or a good match for that kind of workload. And this thing just operates for them, and they have some nice little metrics about how it just hums along, and it's pretty reliable. So that's one. Here's another one, warehouse automation. So Lacote is a big sponsor of Nerves developers. They use Nerves in their warehouses, so it's kind of like a rental model for clothing, and they have kiosks set up all over the place, and a bunch of other devices. They're all Nerves. They're all connected. There's all connected up and all working based on what's happening other places in the warehouse, and with what people are returning or wanting to have sent, and so their whole system's Elixir. Then on that one, see, we've an amazing number of people that are doing indoor farming or farming kinds of things with Nerves. So Bowery is doing this on a big way. They basically rent or own a warehouse and have these pallets. Each one of these pallets has a Nerves device in it that monitors the plants, waters them, takes little videos of them, controls lighting, all that for the pallet. And they just stack these things up in the warehouse, and their farm's automated. And they put these warehouses outside New York City, and then when the food is ready to harvest, they truck it into the restaurants. So that's them. And there are a few other ones. I think the one on the right is one that many people have heard about that have looked at Nerves as FarmBot. Connor Rigby and is on the core team, and FarmBot is this open source robotic farmer that is Nerves based, the whole thing. So it's, if you just imagine a big CNC, if CNC router where you router, except without the router part, they put a little device that can either plant seeds or water or weed. Anyway, they're total open source and very Elixir supporting crowd. And their website has a lot of cool demos of the robot farmer doing stuff. The other one's the other kind of neat one that's out there is this facial recognition beer kiosk, which was running in Las Vegas for a while, at least. I don't know if it's still running, but it was running there, and the taps had a little custom board that was running Nerves that would interface with a few other systems that are around. That's kind of hard to see in this picture, but it basically enable a person to pour themselves a beer at a crowded bar. And then let's see, that's I think those are the other ones. The artificial pancreas one, Tim Mecklin has he actually he's given a few talks at Elixir conferences about this one. So this one's pretty neat to see too. So that's kind of the realm of it. It's none of the Nerve stuff is going to be super small, just sensor, just reporting back to some cloud-based server kind of project. Although for hobby projects, that's totally cool, and I'm not going to dissuade anyone from doing that. But it's mostly stuff that there's enough logic inside to warrant some development, and a company that has developers that are familiar with Elixir or Ruby or people comfortable with this style language that can leverage their skills to program the embedded side as well as other software they may need for whatever they're doing. So that's the gist. Now's the time when I normally talk about, well, why Elixir? And this I suspect will resonate for many of you, because there's probably some reason that all of you have chosen to use Elixir. But for me, it's everything came down to the Erlang runtime. I've been enthralled with this system because it solves so many problems that I've run into in my career as an embedded developer in a particularly elegant way. And so I was super into Erlang, but well, the Elixir crowd has been totally awesome with supporting and contributing to the Nerves project. And I've also I've loved working with the Elixir crowd. So as a result, because as a result, the Nerves project has moved quite a bit to embracing the Elixir ecosystem. But I always like to point out that if you're an Erlang developer listening in, or you like list flavored or LFE, list flavored Erlang, or anything that runs on the Erlang VM, you can actually run it on Nerves. It might take a little setup, and you might have to prepare yourself to use Mix, but you can actually run it. And there have been a few people who have done that. So I'm cutting out some slides here, but I left one in for all of you. If you haven't gotten, so normally at this part in the presentation, I give a little examples of what you can do in Elixir that are particularly neat and don't have a complete analog to other languages. And bit strings is one of those ones where when you're working with a sensor or actuator or something, these come in so handy. And it's kind of funny, anyone who's worked with a hardware engineer, well, when you start working them, and when they design their APIs, you learn that they like to pack a lot of functionality into a few number of bits. It's in C and in other languages, it's always kind of a pain unpacking and packing what they've done to you. And Elixir makes this so easy. Erlang did this too. So the bit string syntax, it's one of those things that when you hit it, when you've been through this pain of packing, unpacking all these bit fields, and then go to Elixir, you're like, oh, this is just the best thing ever, because the stuff that I just wrote matches. And I think the slide, if you stare at it a little bit, and certainly if you look at the help, you can kind of get an idea of what's going on, even though you may not have ever used this sensor. Let's see. All right, so I took out the other nice things about Elixir. So the other things I mentioned are more about supervision instead. And I think, for time, I wasn't going to go into them here. So now, before I go to this next part, is more going over the Nerves stack, part of the pieces part. So I can't see. Does anyone have any questions or want to throw anything out before I start talking about Nerves specifically? All right.
I mean, I'll just say a quick thumbs up for bit strings. That was one of the things that I first learned about Erlang also, because at the time when I was writing PHP to try to like unpack and pack some binary stuff it wasn't an embedded system, but it was a binary protocol. And I was like, oh man, I had to keep hiding away all the details of the packing and unpacking because otherwise the code was totally unreadable. Yeah. And then as I was learning, I think it was the Joe Armstrong book about Erlang, and I came across bit strings, and like you can both assemble and disassemble them in this really beautiful syntax. I was just like, oh wow, that's amazing. So anyway,
yeah, it's just crazy. But I don't know. When I talk to people, some people don't get it, but then a little later when they've had the pain of dealing with these packed binaries, because most of the APIs that you call today, no one's packing bits. People have nice, pretty calls and you don't deal with this stuff. But when you actually have to deal with these bit strings are awesome. And the whole Indian conversion stuff, that bugs that you hit on projects just because, I don't know, someone wants big Indian or vice versa. And
yes,
Elixir just makes that painless. It's just, so anyway, I could go. Bit strings are probably worth like a whole presentation. At least for me, I could count that. I would attend. So
duly noted.
So anyway, let's get to the stack. So I think the big point that I want to convey here is there's not much to Nerves. I mean, there's a lot, but there's not much. And sometimes keeping that into perspective can make some things make sense. The crux of Nerves is to take a Linux kernel and put the Erlang runtime on it. And then it's all your code, right? There's very little there. And many people ask, well, why are you putting even the Linux kernel on there? Because the Erlang, you could argue that Erlang almost is an operating system in itself. And the reason for Linux is to be pragmatic. Most devices that people build, systems that make sense to run Nerves on, have Linux ports for you already. And it's actually a decent amount of work to port to support hardware on devices. And the Linux kernel certainly alleviates a ton of that. So while I don't think any Nerves device can say that it takes full advantage of everything that the Linux kernel can do, it certainly leverages the board support that Linux offers, and also if you have to run any kind of third-party app or library, usually there's some way to compile it under Linux. So this is what it looks like. So the other way to look at Nerves, and this is more of the tooling view, is how you make stuff, and where you spend your time. It's helpful to know. So it's helpful to start looking at this diagram from the right, because what you want at the end is this thing that we refer to as the firmware bundle. It's effectively a binary that you can put on a micro SD card or on some sort of memory that lives on your device. And it's like everything that device needs to run. So this would be the bits that you put on the micro SD card and plug into the Raspberry Pi. So that set of bits would be sufficient and need nothing else to boot the Pi up and run your app. And so then going to the left, there are two forks to this. The upper fork is more the Elixir-centric side, where you start out with your Elixir project, and then you use the Elixir build tools to compile it. So that's good for all of your Elixir stuff, and that's where you normally want to spend your time iterating because it's relatively quick. But it doesn't give you Linux and the other pieces that you need. So that's the other side of the fork, the bottom side. And we have build setup that people go through whenever they're porting to a new board, or they're adding a C library or some C or C++ or some other application that's decently complicated enough that you need the more hardcore embedded Linux build tools. So those go through a set of tooling, and that comes up. The output of that tooling is what's called a nerve system, which is effectively a tarball that has the compiled versions of Linux and the other pieces that you need, and some metadata in it that the Nerves tooling can use to combine with your compiled Elixir code to create that firmware bundle. So let's see. So I was just going to do something really quick, hopefully quick. I was just going to have a little demo of what this looks like. And since I know I didn't have time to talk, I actually have videos showing it work. Now, I should ask, has everyone made something with Nerves yet? Like, have you guys seen it? And so if anyone's saying no, someone's telling me, because I can't see you.
No. Or,
okay.
I've made it. I've got it right here on my desk even.
All right.
Yeah, I think everyone on the call tonight, at least, so I've at least gotten to the point where like I have a Raspberry Pi running Nerves, and I can network, like I can connect to it.
Oh, perfect.
I haven't built like a whole project though.
Okay. So this might be a little bit on the simplistic side, but it shows at least our favorite platform, which is the Raspberry Pi Zero. And I say favorite because it's the one that people usually have the least trouble getting started with. Due to the fact that if you have a Raspberry Pi Zero, all you need is a USB cable, and you can route the Elixir console and Ethernet through that USB cable to get started. Now, long term, you probably will want to wean yourself off that so that you can have it run remotely. But certainly for getting started, it's nice and easy. So let me just go quickly, and I know there's another. I don't want to cut too much into Todd's time, but for anyone looking at this afterwards, the sequence is if you go to the Getting Started guide, you can install the Nerves archive, which has some helpers and has something called mixnerves.new. And you just type that in, and it will generate a template project for you. And I kind of did that real quick while I was talking. At least I played the video for it. So let's just, I was just going to think of the video. I just did a little ls for what the directory looks like. I think anyone who's built an Elixir project will see some familiarity in this layout with the main difference being when you dig into the mix here. I should go back. The main difference being when you dig into the mix.exs, we add a few more hooks there to get the Nerves tooling involved. And I think most people can make it a certain way without editing the mix.exx. But if you start making your own platform, that's where you want to get. That's like one of the first things that you start switching the dependencies around to get access to a different board. So let's see. So I think people are familiar with mixsteps.get. And then the key thing that you start typing with Nerves is mix firmware, which after you get your dependencies, it does the build. So instead of doing mix compile, which you still can do, but that won't do the final step of building the firmware image. Mix firmware will do the whole thing. And thing that I point out to at the very, very end. See that building, and it has the path to testproject.fw. So testproject.fw, that's our output file. That's the firmware bundle that I had mentioned in previous slides. That .fw file can be uploaded over the air to a device. It's typically called over the air when you send a firmware update over the network, or you can tell it to install on a micro SD card, and the route to telling it to install on a micro SD card is this mix firmware.burn. Right, you can see this happening right here. And that's really it that I wanted to show people who haven't used Nerves before. The thing that I like to point out is that if installing Raspbian or any other operating system onto a Raspberry Pi or a BeagleBone, usually the process of copying a image to a micro SD card part takes like 10 minutes sometimes, 5-10 minutes, depending on how much it is. But with Nerves, you noticed it was pretty short. Nerves projects typically result in small firmware images, so that makes them pretty quick to copy to micro SD cards, and that comes in handy when you start getting into the Nerves development process. You're not going to be burning micro SD cards. You're going to be sending new updates over the network or over the USB cable, and it's nice that they're small because that helps shorten the development cycle. So, so just to wrap this up, I use a tool called Picoterm to log into the Raspberry Pi over the USB cable. I know a lot of people like to use screen, but you can see the IEX prompt. And when I was taking this demo, it's just like, oh, I got to find a way to prove to people that I'm actually on the Raspberry Pi. So I dumped the CPU info. And since this is pre-recorded, that's as good as you guys are going to get. But if anyone questioned it, I can certainly whip something up to show you that I'm on a real board.
Can you have the Raspberry Pi hold up a current newspaper, please?
Yeah, okay, I wasn't prepared for that, but I just have a couple more slides, just to level set where things are. The other big thing that comes up is this boot process, and this is the other thing that I think is helpful. And if you're used to programming embedded systems, this is kind of like stuff that you see every day. But if you're not really in the field, you don't really see like all the mechanisms that go on to actually boot a processor and get you to the prompt. And it's kind of nuts when you think about it. And this diagram doesn't do it justice. But effectively, the big steps are as soon as you put power on, it gets this little program that's called bootloader. Depending on which board you are, Nerves provides a bootloader that works with that board, and there's several of them. And the Nerves system, the ones that we provide, will select that for you. And that bootloader we configure it so it knows how to boot the Linux kernel. And then the Linux kernel, when it comes up, the very first thing it does is it looks in /bin/init, and it tries to start whatever's there up as a program. You can put anything there. So what we did was we created a little program. It's called EarlNit, and that little program's sole responsibility is to bring up user space. Believe it or not, user space needs some help to bring up before you can run any program sanely. EarlNit provides the minimal stuff that you need to do, and then it launches Elixir, which let's see, do I show it? No, I don't show it. But as Elixir so Nerves bundles uses OTP releases, and OTP releases start themselves. So when you start up Elixir, it'll start up the release. And talking about OTP releases is probably its own presentation, or at least a significant part of it. But suffice to say, Erlang and Elixir provide mechanisms for starting up processes, and Nerves hooks into that mechanism. Let's see. Okay, last couple things to talk about that. Since you guys have used this, you may have run across that we use a read-only file system, and we like to talk about these things as immutable images. In the embedded world, and I know this is true in many other worlds, just knowing that the bits that you create, in test are the exact same bits, compiled bits that are run in the field is super important. It leads to, since a lot of embedded devices have the problem that you tend to put them in places that you have very little controller access to, and that's that can be frustrating if there's any variability in it. So this is a very important feature, and even in the C and C++ world, a lot of embedded programmers strive very hard to get this. The other nice thing about immutable images is that there's no file system corruption, because if you're not writing to the file system, then you can't corrupt it. Or at least that's the theory. It's that there are some there's some ways that can be broken, but that's another nice property. So we build these images that have all your program and the built-in data in. And that's what Nerves mostly deals with. We have a separate partition, like this is a disk file system partition on a disk where you can write data. So we keep that as separated as we can from your program. And the hope is that when you put this device, somewhere that's hard to get, that if crazy stuff happens, power gets yanked, or there's any number of things that get zapped by gamma rays or something. Hopefully the bits will stay the same. The system can recover, rather than forcing someone to make potentially expensive trip. This slide shows a little bit about how we do it, and I think this is a really simple concept. Many systems do this, but it's kind of neat to know, and you'll start seeing this when you work with Nerves. So the way we do it is we effectively have two file systems. So if you're looking at the picture on the right, there are, and this picture changes slightly depending on which platform you're on. And if you're using Raspberry Pis, this is fairly accurate. We set up several partitions, and we put the programs in what's shown as root file system A to start with, and then when you do an update, you'll update the B little part of the SD card, and then on the next reboot, we point the master. And the important place to point is the master boot record, but we point it so that it runs the software that's in file system B. So we basically ping pong back and forth on updates, and that lets you do something neat. Say you put some software on your Nerves device that's someplace inaccessible, and it's just the worst thing ever. You actually can revert back to the previous build with a reboot. So what some people do is put that on a timer. Like if they can't some people come up with mechanisms for like figuring out whether they like their firmware or not. And one mechanism could be, I can reach this server on the network, right? If you can reach the server on the network, then you know that networking drivers aren't messed up. Your system basically booted. A lot of stuff has to be working to reach and communicate with this and authenticate with the server. So they say, yeah, if that happens, that's good. And so I like that firmware. But if that doesn't happen like 10 minutes, there can be retries. whatever, I'll revert back to the previously running software. And they only do that if right after a firmware update. After it's been marked good, then you'd hope it stays good because the bits are immutable. But that's the kind of things that you think about doing when you have this capability. For the for lawn irrigation, maybe not. You don't need this, but it does come in handy. Let's see. Our ports, I think all of you are using Raspberry Pis, or was that the idea?
Yeah, I think for this first, for the first project, we have like just kind of a recommended list of hardware, including Raspberry Pi 3. So that's kind of what we're all going to start with, but I think it'll fracture very quickly. Actually, someone in the group, he's not on the call tonight, but a friend named Steve already said that he's going to try to do it with the Pi Zero, just to break some, some slightly new ground for himself.
Perfect. Yeah, the Raspberry Pis are very well supported by the core team because we use them. I use a BeagleBone derived board at my work right now, so I support that one a little bit more. But there's quite a. This is the official list, but if anyone wanted to go crazy with custom Linux boards and stuff like that, if it's the rule of thumb is if you can get it running in this tool called BuildRoot, you can get running on Nerves, and BuildRoot supports a lot of hardware. All right, so let's see. Recipes for success. I think this group has already got the first two. I don't know if you guys were going to blink an LED, but actually some of you probably passed that. And then the other thing that I recommend that when you build out your project, especially if it's a bigger one, think about how you can structure the parts to support host side development. Because while you can iterate on the embedded platform that you have, it's frustrating to run unit tests on hardware. So especially doing things quickly. So this statement isn't a knock on Nerves at all. This is a general thing that a lot of embedded software shops do is try to get their software working or debug most of their pieces on a laptop without hardware, or structure the project such that they can break it apart to do that, and not let some of the hardware, no matter how quick the system is, if you can move pieces off of it for regular development, you'll be much happier. And then the last thing is that, and I guess again, all of you probably are aware of the Elixir Slack in the forum, but if not, the core team hangs out. Some of us hang out more on Slack and others more on the forum. But if you post anything there, and I'd actually recommend the forum. A lot of people are, it's a lot easier to refer to previous questions on the forum and point people to fixes than it has been on Slack. So I'd like, unless you need like real-time work, help on Slack, which there's certainly quite a few people who like to do, like to give, but if you can try stuff out on the forum, I think all of us on the core team would really appreciate it, as it'd help provide a resource for our other people learning Nerves too. And that's what I had. So let me exit out of this. So I apologize. I took a little bit more time than I think I was supposed to, but I hope that this helped.
No, it was super helpful. Thank you so much, Frank. And again, I appreciate you being up late at night. It's basically midnight where you are now, I think. So.
Getting there.
Does anyone have questions?
Yes. So if you're ping-ponging between A and B boots, you said all you have to do is restart the device and it would switch back. Oh, is that so? I mean, every time I unplug my Pi and plug it back in, am I switching between the two, or is there some sort of?
You actually have to do work to make it automatic.
Oh, okay.
All right.
So
the default out of the box with Nerves is that only the firmware update process swaps the partitions, or swaps which one that you're on. So if you're running out of A, it will update B, and then we have it so that when you do a firmware update, it automatically reboots. So then it will, on the next reboot, it will swap to B. But if you were to reboot it again, it would stay on B. If you wanted to revert back to A, there's an API call in Nerves runtime and called revert. You just type nerves runtime.revert, and all of a sudden the thing will reboot into the previous partition if it has valid software. We can mostly detect whether the previous partition is valid, and it will let you do it. And so then there are various levels depending on how sophisticated people want to be with automatic reboots. And the Raspberry Pi is slightly limited on the options available to you. Other boards are way more way more featureful. So like they can revert if the Linux kernel goes haywire, right, before Elixir even does anything, and that's kind of cool. Raspberry Pi, it's Linux going haywire would probably brick it.
One quick question I had was, I've heard from a few friends who have done more kind of like Raspberry Pi and Arduino kinds of projects than I have. A few of them gave me the recommendation that if I'm just doing hobby stuff, Raspberry Pis are a great place to start because there's a lot of beginner-centric forums. So like if I needed to figure out how to install, I don't know, SQLite and get that working, that's going to be easy to figure out on Raspberry Pi. But that if I was planning on doing a product of any kind, that I should try to do it on a platform more like the BeagleBone Black, because it's open source hardware, so I could derive my own, and more of those types of features are available. Does that sound like a reasonable? Would you make a similar suggestion to others?
So there's always exceptions, right? So it's totally true. The Raspberry Pi community is awesome. The resources that they have are very high quality. So I would never tell someone not to invest a little time starting something on Raspberry Pi, especially if they're new to hardware, because it's way more beginner friendly and the community is great. Then the second part of the question is okay, if you want to make a product, what do you do? And I think there's a big asterisk there. It depends on what you're going to do with the product. So like, for example, a company like Litote or Bowery Farming, their product doesn't really go outside. They're building a lot of internal stuff, and their numbers of the products, of the units that they're making are, well, Litote is I think that their numbers are more 100-ish, and Bowery is more thousands, but those are relatively low quantities. So for those two companies to use Raspberry Pis professionally, I think it makes a lot of sense. Raspberry Pis fit the hardware works pretty well for what you get for the money. Now it starts getting tricky, and I'm just looking. So here's a little prototype. I have an old prototype of one board that I'm working on. This is I don't know if you guys can see this. This is what you can do with a BeagleBone based board. So the main chip right here holds the memory and the main CPU for the BeagleBone. There's a company that bundles them all together in a real nice way, so you can make prototypes like this pretty quick. They're nice. They very much cater to the professional crowd. So there are definitely some advantages there to working with that group. But and certainly for larger runs, it seems like it's a little bit easier for PTIL to build more bigger quantities with the non-Raspberry Pis. But then you always hear stories. I heard a story this other way of someone ordering 10,000 Raspberry Pis. So who knows?
Wow.
And
It's
apparently
funny
just
just
doable.
Yeah, I'm just surprised that that the company behind Raspberry Pi would be like, okay, 10,000. I mean, I'm sure they're excited about it in some ways, but it seems like their company mission is very educational in nature. At least,
Yeah.
seems like that's where it started.
Yeah. So they're educational. There's they have a line called the compute module. It looks like a little DIMM, like a memory DIMM. That's actually not too uncommon form factor for our little embedded modules. That one's squarely aimed at the professional community. And what you do is you just build a custom board that has a little DIMM slot on it, and instead of plugging memory, you plug in the little Raspberry Pi. I don't know. I can't imagine any other use besides industrial for those.
Yeah.
And I think Bauer is using those in for their project. You get a few more capabilities with the compute module, which makes it interesting. So, there are just a lot of options. It's really hard to pin down one way as being a rule, because every time I do that, I find out about some other company that totally broke it, and it's like working out great for them.
Yeah, I guess it's kind of like, successful products being built on PHP on the web. It's like, well, people using it don't care.
Yeah, they don't care. It runs. That's when I came across PHP on embedded. We loaded the processor up to a gig of memory, and yeah, it ran. And there were issues, I think, that people are familiar with PHP. It didn't sound like they were fazed by some of the things they run into. So, and that one, I don't know if I could say what product this is, but suffice to say, I would suspect everyone on this call has indirectly interfaced with this system. So,
wow,
it's definitely out there. A lot of use.
It's cool. Any other questions that other people have for Frank? All right. Frank, if you need to go to sleep, like I said, you're more than welcome to. You're also more than welcome to stay. We will always love having you.
Yeah. No, I'm up. I'm curious. So thank you so much for inviting me, and thanks, Todd, for getting.
Oh yeah, thank you, Frank.
This is cool. So yeah, if all of a sudden I start trailing off, I'll just hang up. But I want to hear what Todd has to say too. So thanks again.
All right, thanks. Yeah, this is going to be a pretty short introduction to the hardware that goes into your sprinkler system, and luckily that hardware is relatively simple. Let me share my screen real quick. And if anybody can't see my slides, say something now.
I'm seeing it.
All right. Sprinklers 101, my friends. All right. Admire my graphic design skills here, friends. But this is the basics of the hardware that you have in your irrigation system at home. So it starts out with this controller box. Sorry, let me go back. This controller box here. And this is an image of a clock there. So it has a way of keeping track of time on it. These pluses indicate power. So I have 7 pluses there. So this would be a sprinkler controller that can handle 7 zones. So usually, I guess you would refer to your controller in terms of zones. It has a power supply, so it takes AC power in. And so those zones are directed through a low voltage wire to your valve box. And so the valve box is usually a rounded rectangle with a green cover on it. And so if you go in your front yard, backyard, side yard, you probably see one of these things. They're about, about 16 inches by 12 inches in dimension. And so if you open that up, what you'll see inside are the valves that control each zone. And each of those valves will have a wire going to it. And so you have a water supply outside. This is the other side of the valve box. And so this is the, usually you'll have a backflow preventer or a siphon vacuum on there. And that just keeps non-potable water from going back into your house water system. So you'll see that, and this supplies water into this manifold. So the things in blue here in the valve box represent the manifold, and that's where water is going through. And so each of these squares or rectangles there would be a zone, let's say, that directs water out to a sprinkler head out here. So let's see. So yeah, so I'll get into some details about what's going on inside of these separate components. So the controller itself, all it's doing is really controlling power. So when the valves in the valve box receive power, they will turn 90 degrees, and that will cause the gateway to open, and so water will flow through the manifold into the sprinkler head for that particular zone. And so the way we're going to be doing this is by using a relay. So going back here, this power supply to your controller is 24 volts of AC is what it converts down to, and that's what your that's what the valve box, the components inside the valve box are requiring, or what they're looking for. So when they are given 24 volts, they will close the relay. So relays come in two forms. If somebody has a hardware background and needs to correct me on this, jump in. But the more common is going to be in a resting off state. So the one on the left here has 0 volts, and it's in the resting off state, meaning that the circuit's not complete until you give it power. And so this this black thing with all the lines is an electromagnet, and the bar with the red on it is receiving power, and it's currently in the off state. So when you give 24 volts to the electromagnet, it pulls that left side of that switch into place so that it's connected to the right side of the switch, and so it completes the circuit, and that lets power go through. Mike gave us a parts list with an 8 relay board on it, and so the relay board has 8 of these basically on that. And so when you supply any one of them with a voltage on it, it will cause the electromagnet to power up, and it'll generate these circuits. So the board that we have takes I believe it's 5 volts. So the 5 volt is what activates the electromagnet in our switch. And so the board has a 24 volt in and a 24 volt out, and then a 5 volt in as well. And so when you activate it with 5 volts, that completes the circuit, and that allows the 24 volts that you're giving it to pass through. The relay boards that we have can handle up to 250 volts AC. And sorry if I didn't mention that before, the sprinkler controller works on AC. So these, you see 24 volts, that's AC, whereas the Raspberry Pi is going to be giving you between 3.3 and 5 volts in DC. And so this is basically the solenoid valves that are in that valve box, how they work. And so on the left side, you can see a solenoid valve that's shut. And so again, these have a resting off and a resting on. Like there's 2 forms of these solenoids. The ones in your sprinkler box are going to be resting off. Resting off. And so what it does is basically has a spring, and this piece in the center will close off the valve. So you see water on the left, and then it can't flow through to the right. And the pluses represent a cutaway view of the electromagnet that goes around that plug. And so when you charge this up with, in this case, sprinkler components, at least the ones that I've researched, run somewhere between 24 and 30 volts AC commonly. But you can buy solenoids if we end up working on other projects that work on a lot of different voltages. So when you charge this bad boy up to 24 volts, it electrifies this electromagnet, and it pulls this plug basically out of its resting position, so it allows the water to flow through. And that is basically it. So for the purposes of our demonstration, the relay is going to act as the gateway for power to each zone, and the other mechanisms of the controller, such as timing, will be the stuff that we're doing. We'll be programming in Elixir, so we'll be able to tell it when to send power through those pins to activate the relay to open the valve to send water to the sprinkler head. So, and that's it in a nutshell. I'd be happy to answer any questions.
Yeah, anyone have questions for Todd? I think so Todd, thank you for presenting on that. So it's from my perspective, it's mostly good to hear that the research I did was not like totally off base. So I started off this whole thing because you know, I wanted to. I basically like to learn with other people. When I study on my own, like I get lazy. I end up watching Star Trek Next Generation reruns, and so if I learn with friends and we kind of like, oh, by this Tuesday, let's have this working, then I actually get things done. So so I had done some, you know, I saw that Nerves went 1.0. I was like, this is a great time to be doing Nerves with friends. So I wanted to do a Nerves meetup, and then when I was trying to pick a project, I saw a few blog posts, and I had once seen a presentation about controlling sprinklers with Ruby at a Ruby conference. And so I was like, okay, this is a pretty simplistic system, I think. And what I had found was the same thing, that almost all sprinkler valves are 24 volts. I think almost anyone who has sprinklers, if like, you know, I'm sure lots of people in apartments just don't have sprinklers, and I hope that they can do the same project, but with LEDs or something else. But for anyone that does, it probably means, like, actually, let me share my screen really quickly here. This is not a prepared presentation, so I apologize in advance for the ad hoc nature of it. But I took some pictures. This is basically what my sprinkler control box looks like at home. So this is this part up here is actually just like a wall plug-in. So it just looks like a normal thing that you plug in the 2 prongs for your wall. That feeds down these wires that come up from the bottom. And so this is basically, you know, the negative and the positive voltage. You know, it's not really negative and positive because it's AC, so it's swapping between the two. But this is the AC power coming in from the wall. And then the rest of this board, as you can see, there's a ribbon cable where it's receiving the commands from the timing unit that Todd mentioned. And then each of these pins right here, 1, 2, 3, 4, 5, 6, 7, those are the 7 zones. I only have 5 actually being used in my yard right now. But that's essentially what we need to do is take this same power and control when it goes to these pins. And I think actually in my board's case, it's one of these pins down here, one of these terminals, is where it's converted the wall, you know, 120 volt AC power down to the 24 volts that are needed for my valves. But kind of regardless, if you do have a sprinkler system, there's probably a place in your controller box where there is the current accessible 24 volts or 30 volts or whatever. And what you need to do is just get this hooked up to a relay, and then the relays hooked up to these individual pins, because then our Raspberry Pi Nerves project will be able to just tell the relays, turn on this one, turn on this one. And as you turn them on and send power down to that valve, that's when the sprinklers will kick on. So, so I'm hoping that this means that even though I'm sure people have different systems, whatever system you have, it shouldn't really matter as long as you can just take, you know, the negative and positive terminal and pass it through your relay. And once that's figured out, it's just a matter of triggering the relays, and all of us will have the same project from that point. Like from that point through to the logic should be the same for all of us, I believe. So
oh, sorry.
You go.
Oh, okay. I was curious if you had looked at Raspberry Pi hats and if there was one that could help drive the relays that you were looking at.
I didn't look at any. I know of hats, but I've never actually used one in a project. Do you think that would save us a lot of time?
Maybe. I actually didn't know which one would be a good one for it right off because I haven't done a project like this. So I was kind of curious. So I might check in again to see where you guys end up or
Yeah, I think we should look into it. Just even for the form factor of the hat is nice, but I think we might run into an issue with the number of relays. So like I have an 8-zone system now, and I think I actually need 9 zones. So I needed that 9th relay. And so, but effectively it just makes it easier, I think, to interface with the GPIOs. It'll look cleaner, but I don't know that it will. I don't know how much else we could get from the hat other than a clean look, less soldering.
Yes.
Yeah.
I mean, that's the bonus.
I don't even know what a hat is. I've never even heard that. A Raspberry Pi hat.
Yeah, so for anyone using a Raspberry Pi 3, on the side of it, there's all those GPIO pins that are sticking up off the board. And a hat basically is, it looks like kind of another board. So it looks like the flat part of your Raspberry Pi, and it's made just to like mount, and it plugs into all those pins at once, basically. And each hat is going to use some portion of all those pins and kind of make them available so that they're already wired into something else. Like in this case, potentially there's a hat that has a bunch of the relays mounted on its flat surface, and when you plug it into the Pi, it's going to keep that same form factor, but just give you 8 controllable relays, or however many controllable relays. Another nice thing about that might be, because I just, originally when we were just coming up with a parts list, I was like, well, here's these ones that seem to be pretty standard. I can find a bunch of blog posts about them, and they definitely handle enough power, but it turns out they handle like 10 times the amount of power we actually need. And so they are probably overly sized. And at least in my case, I tried to take it out the other day to the garage, and I won't be able to easily get my set of relays to fit inside the existing box. I was hoping to like get it inside the box so that I can just close that. And I have 3 little boys. Those are my kids. And I know that if they see any wires or blinking lights, like they're going to be all over that thing, and it's going to be off the wall in no time. So I was hoping I could use the existing enclosure and just like tuck it inside with my Raspberry Pi and my relays. And that might be tricky to do with the set of relays that we purchased. Or if you want more than 8 channels of control, then like Todd's situation, then I think you might want to do that as well. So I think the parts list we have still works great as a getting started point, but yeah, let's do a little bit of research. So I'll take that on for before we meet the next time. I'll look into getting a hat with relays.
Just a quick note too. So sorry, John. Is that your sprinkler system is designed to generally just have one zone on at a time. So we're gonna be given a lot of power here. So we could activate all 8 relays at the same time if we wanted to. And the system will work. It will turn on those solenoids, but you're most likely not going to have enough water pressure to push the sprinkler heads out of their little housings. So if anybody does that and is like, whoa, man, my sprinkler heads didn't pop up. I wanted to like save time and water my whole lawn in 7 minutes. Just keep that in mind. You probably need like 600 PSI in order to do that, and your city water pressure is probably like 80. So
buy a water pump in addition to the Pi hat.
Yeah, boost it up. You'll probably break all their sprinkler lines when you do that too.
Yeah,
please do this.
Yeah, let's
please
just
do this. Make a video, and it'll be an awesome Nerves video.
Maybe I'll try.
The Nerves part will be such a small part. That'd be awesome.
Maybe I'll try 2 zones at a time. I have to actually step down my pressure because I've got about 160 pounds in the lines.
Oh wow!
So we have to step it down to 80. But this is Idaho Falls.
Nice.
Half the people are on their own wells, so yeah.
Yeah, so if you go into your valve box, you can activate the solenoids manually. So if you just, usually they have a diagram on it of which way you should turn it, but if you give them a quarter turn, you should be able to actually run those manually and see how many of them you could run at the same time and still have it work. So
yeah, that's cool. Go ahead, John.
Okay, sorry. I was like continuing on the last 2 threads ago. I actually I don't know if we could do hats, but I really enjoy woodworking, so I bought some walnut wood, and I'm actually making a box to hold all my relays and pie in. It's going to be right next to my wall. And so I have these porch lights outside. They're really nice, but there's only one switch, and it's at the other end of the garage where the sprinklers are. So and I only have 4 sprinkler zones. So that's my plan for the other half of the relays is I'm going to try to make Alexa turn on my garage lights. So I don't have to freaking walk out there all the time when my kids leave it on.
Yeah, one of my add-on projects, so I have 2 add-on projects that I think I might do after getting the basic sprinklers working. One is that, so my kids have a tendency of leaving the garage door open because they have like a little Power Wheels car, and my 3-year-old is very adept at driving it. I don't know how, probably just seeing his older brothers or something, but anyway, he constantly opens the garage door and goes out and drives. And we never remember to check it until we're both in bed. And so usually it's like 11 p.m. and my wife rolls over and she's like, hey, can you go check if the garage door is open? And I never want to say no, but I never want to say yes. And so I really want to get to the point where I can actually just like check it from my phone, or potentially even close it and open it from my phone. And I had kind of the same idea, like maybe being able to detect the status of like whether or not a door is locked. So that might be one. And then also my wife is quite into gardening. And right now we are just using, like her garden gets also kind of covered by some of the sprinklers, but I think we might want to split out some zones so that we can more distinctly control how much water is going into her garden areas. And so I might, similar to Todd, I might end up kind of adding some additional zones so that I can have finer grain control of where the water is going and when.
Yeah, one idea that I had too was there are moisture sensors that are very small and very cheap, and so it might be a good add-on too if you want to actually use one of the GPIO pins to like put moisture sensors in your garden, and then it can turn itself on when it knows that it needs water. So there's additional hardware and a little complexity to that, but it should be pretty trivial to do that as well.
Yeah.
And as far as garage door openers, let me know if you get into that, because one thing I learned about garage doors is that there's one button and it does many things. And so it actually is not just a simple relay, just like a simple toggle. It actually, like to turn on the light or to open it or to continue from where it left off, it actually does change. It sends a different pattern across the wire from what I could understand, but I couldn't find a wiring diagram for my Chamberlain garage door opener that showed what that big string looked like. So.
I had the same idea, and I was just thinking, I found a 50-cent garage door opener at Goodwill and programmed that for my house. I was just thinking to tie in right where the button is. So all I have to do is mimic a button click and maybe keep track of my own state. I don't know. I hadn't really gotten that far, but I thought I could at least take over the button.
Yeah.
And just like sit it in my box.
That was when like I had a really like my first really hacky Nerves experience was actually that I had bought, one of my kids had saved up some of his money and had bought a really bad remote control car from Walmart. It was like $10 bad. And pretty quickly he broke stuff on it. And I just wanted to know like, oh, could I control it from my computer? So I actually like, I didn't figure out the over the air signals or any of that. I literally just patched wires. Like I took apart the handheld controller and just made it so that I would like close connections as if someone was pushing the physical button. And I just did that from a Nerves device. And that was one of the intros where I was like, for me, that was, again, like I want to say a big thank you to Frank being on the call and for having done this project, because as someone who like literally for years and years, I've wanted to build this kind of stuff. I've wanted to get into robotics, but also just other forms of having code interact with the physical world. And for so many years, I would like pick up a project and I would get to the point where I'm like, okay, I'm pretty sure I can do this in C. And then it didn't compile right. And I either bricked a device or something. And I would just be like, okay, I'll come back to it later. And I never would, because it was just too painful. It was too many small speed bumps and I didn't have enough of a reason to complete it. And Nerves was like one of those projects where the first time I picked it up and got something up and running, I was like, whoa, this is amazing, because I can actually imagine myself completing projects with it. So a big thank you to all the bump smoothing that you've done, and other people in the Nerves team as well. That I just think that's a pretty amazing thing. And I feel like it's a really lucky time to be a programmer, because it means you can bridge between these two worlds without a career's worth of effort.
Mm-hmm. Oh, I really appreciate hearing that. I'll pass it on to the rest of the core team. So it helps. There's a lot of pain that we sometimes have to go through getting these things to work, but it's really nice to see the outcome when they do. Yeah.
Thank you again very much. And I, if we can help anyone else, like I said, we'll be posting all these videos. So I think I don't actually imagine if the group gets quite a bit bigger. I've had kind of varying levels of interest from a lot of people. It's sometimes really hard to do video conference calls with a lot of people on them. But we'll always be posting videos, so people can always follow along. They can always reach out to us and suggest topics that they want to learn about. And hopefully this is just a good resource for other people getting into Nerves or into the embedded space in general. So the last thing I wanted to talk about is just some rough plans for the next time we meet. One thing I wanted to just get a quick pulse from the group on is, do people want to wait until the first Wednesday of September, or would people be interested in potentially meeting like August 22nd in about 3 weeks from now? Because I think I can make some decent progress on the project in the next 3 weeks. So just a quick thumbs up, thumbs down, Todd or John, either of you, does that work? Good for John. Todd?
Good for me.
Let me double check. So the first Wednesday is the 5th. So that's ElixirConf week. So it'd probably be better to do it a different week.
Okay, yeah, so let's do it August 22nd then. You can, if you need to practice your talk, you can practice it on us if you want to.
That's okay.
But, oh yeah, you've given it before, or versions of it before.
That'd be a spoiler. People could see the video before the conference.
We'll have to post our video later or something. No spoilers. And then I thought in terms of topics, it'd be good. So John posted a little quick video on Twitter. He has his Nerves kind of wired up and has done the basics of getting the Nerves project with GPIO connected and then controlling those in order to control something that has a higher voltage than what would be safe for the Raspberry Pi itself to flip on and off. And so I thought John could give us a quick primer on like how to get from where our devices are now up to there. Also, I posted a blog post on just getting, it's just kind of like, here's commit by commit, how to get from a mixednerves.new to a Raspberry Pi that you can push firmware updates to. It's connected to your Wi-Fi, and you can get like an SSH console into the IEX session. So it's not a ton of steps. So I was going to post that and kind of leave that as homework for anyone that wants to kind of catch up and join the group. I'll share that blog post on our Twitter feed, and then John can give us an introduction to GPIO and relay control in a little bit more detail. Is there any other topics that we think we should cover for next time?
I think maybe some communication methods, like if we mount this in a box, what are some ways that we could, what would be some good ways to then have like some sort of centralized app that could know the state of the controller? Maybe that's like the next week, but that's kind of what I've been looking at right now. Just playing with ideas.
I would like to. I mean, I'll just maybe open it up and I'll post this. By the way, also, I keep forgetting to mention, we do have a Slack group where everyone who is kind of building the project can communicate. And if you run into bugs that seem specific to sprinklers and stuff, you're welcome to ask the question there before you go to the Elixir forum or the Nerves core team on the Erlang, the major Elixir Slack. And so you're welcome to ask questions there because people will hopefully be running into the same issues as you around the same time. And so feel free to ask questions there. I'll post an open request there as well. I think it'd be good just to get maybe some proposals of like, how should we structure the project? I was asking myself some questions of like, do I want to keep the schedule of when valves turn on and off? Do I want to have that stored on the Pi itself? Or do I want it just to send it a message whenever I'm about to turn one on or off? How much do I need access to the device and to the logic of the controller remotely? And you know, as Frank brought up, Elixir makes a lot of those choices very flexible. Like, we have a lot of potential ways of doing it. And so I think it'd be good just to maybe get a few proposals of what functionality do people want out of their controller, and maybe some suggestions on how they would want to structure it. And so maybe we can kind of just discuss some potential ways we can do it. And then the next time we meet after that is when we can have someone actually present on taking one of those ideas and getting it implemented. All right. Well, thank you everyone for making time tonight. I really, really appreciate it. As I said, for me, it is always so much more fun to learn with friends. And it's always interesting for me to learn from other people's stack traces instead of having to make my own. So many thanks to everyone that's jumped in. Thank you to everyone who presented tonight and people who are getting ready to present for next time we meet. Any final questions or thoughts that people have? All right. Okay. Well, thank you, everyone. And I'll keep you guys all updated and let you know if anything changes.
All right. Bye, guys.
Good night, everyone.